So today's our lecture will be based on the solving of examples in retrosynthetic analysis. In the last lecture, we learned about the basic concept of retrosynthetic analysis. So what is meant by target model and what is that the retrosynthetic analysis. These steps are very important. So we learn that the basic idea about this, the how the disconnection is happening, what are the symptoms, what is important, how the function will be done. So now, before proceeding to the synthetic problem, so there are some few steps we have to understand. So here it is the first step is that study of target molecule. So what is the target molecule you want? You should look at the target molecule and study carefully what are the functional groups are there. What are the different types of functional groups? And if you find there are some function groups, and if you find there are some function groups, then you should go for the FGI, that is nothing but the function group interconversion. Okay, suppose you are not able to find, or if you don't have any, if you don't find out any function group, then look forward for the polar bonds in the model and do the disconnections. So there are different types of disconnection. If there is a function group, then you can convert that function group into another function group by applying FGI. If you don't find that function group in that molecule, so you should go for the polar bonds which are present in the molecule and do disconnection on that one. And the last most important step is that repeat the steps 3 and 4. So these are the important steps while we are doing retrosynthetic analysis. Finding a function group, if it is there, then convert that into FGI. If it is not there, then you should go for the polar bonds. So these steps are repeated until you reach a simple structure which will be your reactant, or one we can call it as a starting method. Okay, so these 5 steps should be remembered while retrosynthetic analysis. So here it is we are going to consider a problem. So you can see here this is orthochlorobenzoic acid, right? Now this one is our target one. Okay, so now we are going to find out there are different groups. Chlorine acts as a substitute. So first we are going to, as according to our rule, if the molecule possesses function group, then we should go for the function group interval. Now here it is we are going to consider this molecule. This is COH group and this is fluorine. Now here is the function group. So basically we are going to convert this COH group into another function. So this is the exact reverse of our regular reactions, right? So the product E corresponding alcohol. That carboxylic group is converted. You can see that this is. So we are going to write down this COH into corresponding alcohol. That is known as FGI, function group interconversion. Okay. Now in the next step, again we are going to convert this particular group into a different functional group. Where it is, the fluorine is as it is, and this alcohol is converted into this alkane. That is CH3, right? Okay. Now again this is FGI. This is again FGI. Okay, we are going to remove the function group since from this carboxylic acid to alcohol to this methyl. Now again we are going to apply the retrosynthetic analysis. Here it is we are going to discuss because there is no any kind of function group in there. So as per the rule, we should claim this particular bond. So here it is we are going to claim this bond. So this is known as disconnection, right? Disconnection. And the product is here. So you can call them as a symbol. So these are nothing but the symbols. Okay, because they are charge traces, right? Now the synthetic equivalent for this one is. Okay. Now then we are going to claim that one. We are going to again disconnect this molecule because there is no any kind of functional group is there. So we are going to claim this bond and now converting this into corresponding, again these are the syntones, and the synthetic equivalent for can say that this is orthochlorobenzoic acid, right? And this one is a benzene. is by applying retrosynthetic analysis to different types of operations. Here it is, there is no any kind of we are going to apply. No function group, so we can see in the both the structures we get a very simple structure. This one is a very simple structure, or you can call it as a reactor. So in this way we can disconnect the molecules by applying the retrosynthetic. Now here it is we are going to consider the synthesis. Now exactly we are going to actual reaction. Okay, this is the exact reverse of the reaction. Now we're going to follow this path. So first we are going to take this benzene, then we are going to chlorinate that particular benzene, then we are going to isolate that benzene, right? Then we are going to make it alcohol, then we are going to oxidize this step. So we are going to follow these steps. So the first step is the chlorination of benzene, right? Take benzene and we are going to react that benzene with the chlorine gas in presence of anhydrous AnCl3. So this is known as Friedel-Crafts reaction. So we get the product like this. Okay. So this is a chlorobenzene. Now in the chlorobenzene, again we are going to consider the Friedel-Crafts reaction with FC reaction. That's CH3. So this is of a fluorotoluene. Now third step is that we are going to oxidize this molecule. Seriously, mild oxidizing reagent. Then we convert that CH3 into corresponding alcohol. But if you use a strong oxidizing reagent like that, potassium dichromate oxidizes. This is our product, that is orthofluorobenzoic acid. So in this way, how we can consider a target molecule, and by applying retrosynthetic analysis, we get the simpler starting material. And then again, we are considering this simpler starting material by performing some reactions such as Friedel-Crafts, acylation, alkylation, oxidation. We get our target molecule in a good yield. So that is the beauty of retrosynthetic analysis. Okay. So now let us understand another example. Examples. Here it is, we are going to consider now a revolted synthesis is there. So by applying nitration process on the 5 degrees Celsius. Only the changes occur in this group to be active. That is diazonium salt. It is a diazonium salt. Diazonium salt is substitution reaction of in presence of this copper bromide, and this particular group is substitution. This one is the reported. Now, but there are different types of reactions, different types of mechanisms we can use for this. Similarly, in the first case, we are going to alternate route, we are going to use for this one. We can nitrate it